Record to the cloud. For the first question which you had, that how is the marking scheme? The marking scheme is divided between, I should say, two very important criteria. The first one is going to be your midterm, then your final term. Your final term has, I should say, 30%. I'm just going to put that also in details onto the Schoology website, but also that's a kind of a review for it. It should be around, I should say, 30% for your final exam. And I should say the rest of 70% is going to be divided between the two projects which you're just going to do, your presenting which you're just going to have, your quizzes, and also your homework. Each homework consists of, I should say, around 2% of your total mark at the end. And for example, the one which is for COVID-19, it's 20% extra on top of the things which you do. If you go to the Schoology website, there is one extra project. It means that, for example, if you get 70%, I should say, on the sum of all your midterm, final term, quizzes, projects, and your presentation, what you have done based on the quality of your work, if you have done something on, I should say, COVID-19, based on the criteria and the rubric which I posted in the website, you can get up to 20% extra.
Can I ask you one more thing?
Yeah, sure.
About the presentation. Can I just like make my presentation in a different way? Like I shot a video, then edit it, and then send to you. Like
that's the plan actually, Oliver. If you remember, I just mentioned the website is screencast, and that's how you can just make the presentation. And your answer also, your suggestion also, it takes me to your second question, is that how to present your work. Your work which you submit, it has to be submitted in two different ways. The first submission is going to be on the Science Club, which you also, for example, if you have made a video, you provide the link to your video there as a blog, and also your writing, it should be on the Science Club. It's that the first thing, and also when this is finalized there, then when you have made edits and you just improve your work, then finally you post that on the Schoology website. But the main thing is that you have to post it onto the Science Club. And if you want, for example, for your presentation, that's right, you can do whatever you want. You can record yourself. You can just have your PowerPoints or anything, or make a movie, whatever, and put it on YouTube, and you provide us a link then.
Sir, did you see my last project about the bacteria?
Your last project about the bacteria?
Yes, the modeling bacteria growth and decay.
That's right. That's right.
Is that okay if I make a video like that?
The thing is that there is a criteria about the length of the video. The video is fine, but about the length of the video, I'm just gonna think of it, what is gonna be the best option, then how much you have to record it. But the quality was good, but I mean, in terms of the length, how much it has to be, then that's gonna be the thing that when we get closer to the time of the presentation, I announce how much time you have to spend for the presentation. Between, let's say, maximum, I think 20 minutes should be fine.
Okay, thanks.
Awesome, no worries then. But I think, Oliver, you're on the Science Club. I saw you there.
Yes.
Yeah, nice. And also, I should say the deadline for the projects is coming up. All of them. Okay, and now, guys, let's start for any other questions, guys.
No
questions.
Okay. Sir, did you post the link for the project about some, because I did research, I found nothing.
For the Hodgkin-Huxley?
Yes, and for the mathematics and application. for the
And just for example, Oliver, the first option, for example, I'm just gonna provide some resources online on the Schoology website. I'm gonna do that at the end of the session today. But the main first link which you can find always from the Wikipedia, it starts with the explanation of what is the model. And if you scroll down, it shows the mathematics behind it. But as I said, you do not need to, I should say, derive the mathematics. As long as you know that there is a system of equation describing the behavior of the brain, and that's enough then. Then you explain qualitatively that what is the model about? Is about the channels that they transmit ions, for example, inside the nervous system, and it causes a polarization to move along the axons, and which is called action potential. For example, that's the mathematics described. But I'm gonna put more links to the website, which you can see some resources, I should say.
Okay, thank you.
Yeah, some resources. But that's a very interesting project. I'm sure that this is the best thing you can ever do in the math in the high school sessions then please always ask me your questions, and if there is any concern, put that on the Schoology that everybody can just get back to it and answer the question then. Okay, and now let's any other questions, guys? Nothing? Okay. Guys, by the way, today we have, I should say, where are the others? We have lots of absentees. Today we have a guest speaker, Professor Zhu. She's going to join us by, I should say, by, I think, 10:15. Then we finish the session by 10, that they can have a break. Then we just come back by 10:15, that he's in the class to share, I should say, to talk about the topic then. Okay, guys. Now today we just move on to, I have changed my papers because I ran out of the other ones. The blank.
Wait, what are we gonna do?
So what?
What are we gonna do?
Today.
What are we going to do?
Yeah, today we are going to talk about until 10 a.m. we are going to talk about the trigonometric identities.
Oh.
April 23rd. Advanced function. Guys, I'm gonna ask you to, as a kind of an homework, I'm just gonna, because we do not, I was planning to prove it, but I put the proof for tomorrow. And also today, we have to talk about the dates. We have 3 sessions. We have to cover 3 sessions. Then we have to decide the dates that we are going to do that. Today, we are going to talk about the sum and difference identities. And as a homework, you have to just post the proof to me. You have to prove it and send it to me as a homework, how to prove these ones. We'll review this and apply this, but the proof is just as a homework. You have to submit it tonight to me then. And we could read, I did a proof tomorrow myself, but tonight you just do the proof yourself then. Okay. We are going to talk about, I should say, the sum formula for the trigonometric identities. Guys, can you see that? The color is fine?
Yes.
Thanks. We're going to talk about this one. These are the things that you have seen that I should say on the function 11. The first one we're going to talk about, I will go to the proof tomorrow, because by 10 we have to finish and get ready for the lectures by Professor Zhu today. Then I just write the formula for you today, tomorrow I will prove it to you. And also you as a homework, you prove it today for me then I'm just gonna only review the the formula. The first one that we're gonna talk about is gonna be the cosine function. Cosine, if you have an angle, which is you have two angles, which is, for example, alpha plus beta. The first formula, which we're just going to cover today, is going to be this. Cosine alpha, cosine beta, minus sine alpha, sine beta. Guys, you have had this formula in function 11, correct? Mingji, Oliver, Brian, Linda, Sean. Guys, are you there?
Yes.
Yes.
Yes. Have you had this formula in function 11?
I forget.
Oh, you forgot it. Okay.
Yeah.
No worries. We're gonna talk about that a lot and nothing to worry at all.
Okay.
Okay. For example, and this is the first function that today we are just gonna work with that today. We prove it tomorrow. And also the other formula is this one, the cosine of alpha minus beta, which is essentially, you call that the cosine alpha, cosine beta, but this time, because this one is minus, it becomes plus. Sine alpha, sine beta. These are the things that we talked about that I should say in function 11. We review that today, but tomorrow that's going to be the main proof. And you also do the proof today as the homework. Okay, now, for example, these are two common ones. I'm just going to give you an example. Imagine that we're going to talk about, for example, the cosine of 45. As an example, I'm just going to write about the cosine of, let's say, talk about 45 minus 30. Today we are going to talk about this one. For example, what is a cosine of 45 minus 30 degrees then? Okay, you say that, okay, how am I going to do this? I'm just going to use this identity. If you wonder why these identities are valid, that's the thing that we're going to talk about that tomorrow. Okay, now, based on the identity which I have written, I call that identity number 2. It's going to be very easy. I'm going to expand my cosine into all these individual, I should say, angles. The first one is going to be the cosine of 45 times cosine of 30. But this is minus here. I'm just going to put plus here. Plus sine 45 sine 30. Okay, any questions, guys, so far?
No.
No?
Yeah.
Okay, then what's going to happen now? I'm just going to plug the values there to see how much how can I get that. Okay, guys, how much is a cosine of 45 degrees? You had it from function 11, huh?
Root 2 over 2.
That's right. Thanks, Mingjae. Root 2 over 2. But how much cosine 30?
Root 3 over 2.
That's right. Root 3. You can just, guys, memorize it. You can just, I'm just going to provide the list to you. You can memorize it in the test. I'm just going to give you the answers for it. Then I get plus. How much is sine 45?
Root 2 over 2.
That's right. How much is sine 30?
1 over 2.
That's right. 1 over 2. Okay. Then if you simplify that, how much is that going to get? It becomes square root of 6. It becomes 2. And you get the 2 as, I should say, the common denominator. Then you get what? You get the square root of 6 plus square root of 2. Because these two, when I multiply that, I get what? The square root of 2 times the square root of 3 becomes the square root of 6 plus the square root of 2. And I have 2, I should say, as a common denominator. But no, sorry, 4. 2 times 2 becomes 4. And that's the final answer. Which essentially is what? Which essentially is the cosine of 15 degrees. Guys, look at that. Why this identity was very useful. And as you can see, when you have two angles, for example, cosine 50 degrees, and you do not know how to find the value of the cosine 50, because you know, for example, you have some special reference angles, if you remember from, I should say, function 11. But if you have forgotten those concepts, I have covered those lessons in function 11 class in a very detailed, I should say, instruction how to get the reference function for 30, 45 degrees, and 60 degrees, because we know these reference angles in the first quadrant of the unit circle. Then if you get, for example, cosine of the 50, and when you want to decide how much is that, but you do not know the special angles for this one, because that's not a popular angle. It's not either 50, 15, it's not either 30, so it's not 30, it's not 45, it's not 60. These are my reference angles, which I had a complete knowledge about their trigonometric ratios for the sine, cosine, tangent, and cotangent. But for 15 degrees, I have no knowledge. Then I can express that in terms of two reference angles, which I have a complete knowledge of what is the cosine or sine angle. Because from function 11, and particularly from the knowledge of the reference angles, which is 13, 45, and 60, you can always transform these 15 degrees to the sum or the difference of two reference angles. I know how much is 45, I know how much is 30, then 45 minus 30 becomes 15. And that's my strategy then, to start by two angles, which I have in knowledge. Then for sure, I know that the cosine of the 15, it's gonna be this amount here, which is expressed in terms of the reference angles 45 and 30. And you see this identity for the cosine is gonna be very relevant in the cases that you just want to find the angle, which you have any knowledge of this thing. Okay, any questions, guys?
No.
No? Okay.
No.
And now if you got that one, I'm just gonna ask you, please, as a quick, I should say, homework based on the thing which you did, and now please come here, using the reference angles, find the answer for this. What is the cosine of 75 degrees then? Please do spend 2 minutes on it. Good morning, Sean. Good morning, Arya.
Good morning. Cosine 75 is root of
Morning,
6
teacher.
minus root of 6 minus root of 2 divided by 4.
That's so true.
Yeah.
And let others also to put that on a paper. Guys, by the way, when we have, I should say, the guest speakers coming on, I should say by 10:15.
Start with the video.
Morning, teacher.
Good morning, Arya. How are you?
Good.
Awesome. Please, when the guest speaker comes, as a courtesy to her, please make sure that you have, I should say, your the camera
Cameras on.
on. That's right, because it's a kind of a respect to that prof. She's also from China. If you want, you can speak to her in Chinese then, if you feel more comfortable.
This still counts?
Huh?
Oh, I just get up. I mean, I didn't wash my face, and
We have a break by 10:15. We come back. You have 15 minutes to
okay,
to get refreshed.
whatever. Yeah, whatever.
Okay. Okay, guys, this one is going to be very easy because the cosine of 45 becomes what? Cosine of 45 plus 30. And you can follow the same thing which we did, but you get the minus sign there. It becomes minus square root of 6 minus the square root of 2 divided by 4. Then it's going to be very easy then. Becomes the square root of 6 minus the square root of 2 divided by 4. Okay. Okay. Now, I'm just going to ask you guys for this one. You have the second question. I'm going to just ask you to compress this expression. The expression is going to be this one, cosine of 12 degrees times cosine of 3 degrees minus sine of 3 degrees sine of 12 degrees. What is the compact form of this one? Guys, are you done? Who's done? Linda, Arya?
Not yet, teacher.
Sean,
Yeah.
you were saying once you were going to talk about the MRI from physics 12.
Really?
Yeah, you said that you are interested to do that.
Yes.
Yeah. I have a project for you or anybody else who's interested, but it also involves calculus, and it involves calculus, advanced functions and physics for MRI. If you are interested, you can also give a presentation to the class for extra mark. It's called Gibbs phenomena. Search for it. It's calculus and MRI and physics together. And signal processing. Okay, guys, what is that? And Ninja, Oliver, also you too, Linda, Brian, who, the more project you are more welcome to just do that. Okay, for this one, it becomes easy now, guys, based on the identity which we learned. What identity we learned? We learned that the cosine of, let me change the color. The identity which we learned was this one. We learned that, guys, the cosine of two angles when they are summed becomes what? For example, alpha plus beta becomes the cosine alpha, cosine beta minus sine alpha, sine beta. That's the identity which we learned. And now look at this one. I have something similar to this, but from the right side. I have the cosine of two angles multiplied to each other, which it is subtracted from the product of the sine of the same angles, which it reminds you of this identity, which it tells you you have to just add it as the cosine as the sum of these two angles. Your alpha is going to be, for example, your alpha is going to be 12 and your beta is going to be 3. When you sum them together, it becomes how much? 15 degrees. We're going to use this identity just when we just want to I should say, to reduce some trigonometric functions in future when we are working with more advanced identities in future. Any questions on that, guys? Nothing? Lindsay, Oliver, Linda, Aria, Brian?
No.
Nothing? Okay. Guys, you know that when you do not have any questions, that's my turn to ask you questions. Okay. Guys, this is my question for you. I give you that I have an angle which I know the sine. Hey guys, I collapsed. My laptop fell down. Okay, my question for you is this. I say that I have an angle which I know the sine of that angle. I know that the sine of angle is 5/13. But above this, you know that it's gonna be the terminal side in, let's put that in the quadrant 1. And I know the tangent of alpha also. Now, let's go to the other one. The tangent of the beta. It becomes minus 27, no, 20, let's put 24. 24, let's make it rounded to 7. Which is in the quadrant 2. And I'm gonna ask you this question, guys. Please spend some time to think of it. That's a very important question. In your test, you have similar stuff like that. What is the cosine? Alpha, let's put it as a plus. Okay, guys, let me explain to you what happened. We have this one here that we have. Everyone see what I have written?
Yes.
Awesome. Guys, look at this. We have sine alpha, which is decided to be 5 over, that's that I'm gonna. Sine alpha is 5/13, which is, we say that if you just draw the unit circle, the terminal side of your angle is in the first quadrant. I have another angle, which is beta, which says that the tangent of the beta is minus 24 divided by 7, which is in the second quadrant. I mean, for the beta angle, the terminal side of your angle in the second quadrant. I'm going to ask you, what is the cosine of the sum of these two angles? If you are wondering what I'm talking about the quadrant, I'm going to explain it to you in a second. In order to explain the quadrant, I'm just going to draw the Cartesian coordinates and draw a circle which its radius is unit length, which it means that it can be 1 meter, 1 centimeter. And if I have an angle, which is this, for example, this is going to be I call it alpha, for example. You see, it's going to be in the first quadrant because it's both x and y. It's going to be positive. You know that from function 11. First quadrant, second quadrant, third, and fourth. Please answer this question and find the cosine of that, the sum of these two angles. And please let me know when you're done. Okay, who's done? Mingje, Oliver, Sean, Linda, Arya, Brian. Guys, are you done? Hello?
Not yet.
Oh, okay. How about 1 minute, huh?
Okay.
Okay, guys, can I just continue and you follow me? Who's done? Hello? Oliver? Mingji?
I'm not done yet.
Ah, is it hard?
Yeah.
How about you, Linda, Arya?
No finish.
Guys, some of the students are absent. They had to be present today because of the guest speaker.
That's right.
If you have cell phone number of your friends who are absent, give them a text and let them know that they should be here on time by 10:15. Who is absent today? Today is
David.
David and Samantha and who else? That's pretty much.
What about function 11?
I have told them they can just join us.
Oh, at 10:15.
Okay, I'm gonna solve it myself. Who's done? Ninja, are you done?
Yes.
Great. Okay. Guys, look at that. The first thing, Linda and Arya, are you there?
Yes.
Brian,
Yeah.
awesome. Minjay, you are there. Sean is there. And Linda. Linda, are you there?
Yes.
Okay, great.
Yeah.
And Arya, are you there? Okay, let's do that, guys. The thing that, how to start? The first thing that I have just given, I should say these points that I know the sine alpha in the first quadrant. The sine alpha in the first quadrant is denoted by this, if that's going to be the first quadrant. What does it mean this is the first quadrant? It means that if I know the sine, by definition, I know the definition of the sine of an angle, which I know it's going to be like that. I know by the definition that the sine of an angle I know by definition the sine of alpha is what? If I call this one, let's say, if I call this one x of the alpha, and if I call this one y of the alpha, and it's gonna be, what is the definition of the sine alpha? I know that the length in front of the angle divided by the radius, correct? That's what we learned. We call, for example, if there is a point, the point is denoted by A, and A has, I should say, X and Y coordinates. With respect to these Cartesian coordinates, I know that if I want to construct the sine ratio for this point A, which is observed by the angle alpha, it's very simple. I pick up the Y coordinates divided by the R of my unit circle. But I know that the R is 1, because we're talking about the unit circle, and that's essentially, that's we can call it as y. But now here, we do not have a unit circle. We have this definition, y divided by r. But here, if you look at this, I have, based on the definition of the sine alpha, what I have given to you is that sine alpha, if you look at this, it's what? It's 5/13. Correct? Then if that's going to be 5/13, I'm just going to write it in front of this. You see it if I write it here? 5/13. Then based on these guys, how much is my y? It's going to be 5, huh? Because they are just in front of each other. You see that? Then y is going to be 5. Then how much is going to be the r? R is going to be 13, correct? Yes, guys, is it correct so far?
Yes.
Awesome. Then based on that thing, this is now the Pythagorean theorem. You can use that because if I have y equals to 5 and if I have r equals to 13, you know that there is an identity, and that identity is this, that from this angle, you see that x squared plus y squared equals to what? R squared. How much is my x? I have no idea. How much is y squared? My x squared, I don't know. My y squared is, what is y? 25 equals to r squared, which is 13 to the power 2. Then you can get x equal to what? 12 unit. This is going to be my conclusion from this part, I should say, of the book. Is it clear, guys? Then, based on the first trigonometric identity that we had, then only based on the first trigonometric identity, I was able to understand what is the x, what is the y, and what is the r. Based on the first one, I knew what is the y based on the definition and what is the r, and I used the Pythagorean theorem to find what is the x, correct? Then as long as I know the x, can I find the cosine of the alpha? Linda, what is cosine of the alpha? Linda,
Yes.
what is cosine of the alpha here? I write it here.
This color I no see.
Oh, this color. Oh, okay. Sorry. Let me change the color. Let me. How about this?
Good.
Better? Awesome. What is the cosine of the alpha, Linda? Based on the definition, it's going to be this, the value of the x divided by the r. What is my x? I found it, it's 12. How much is my r? It's 13. Correct, Linda?
Yeah.
Huh? That's right. I only did just the definition of the cosine of an angle.
Okay.
So far, so good?
Yes.
I'm so glad to hear it. Okay, that was only for the first angle which I was talking about this, which is the first quadrant for the sine alpha. Now I'm just going to go to the angle beta, and let's see what's going to happen there. Okay, for the beta, things are going to be much easier. Why? Because imagine that this is going to be my Cartesian coordinates. And for these Cartesian coordinates, I do this, I draw the unit circle, and based on the thing which I knew, that the tangent of the another angle is minus 24 divided by 7, and I know that the angle, the rotating arm of my angle is the second quadrant, I come here and I show my angle here. It's going to be on the second quadrant. Everyone can see that?
Yes.
Yes, great. And it's going to be my angle beta. Okay, but I have the tangent of the beta. Linda, can you see this color?
Yes.
Tangent of beta is minus what? 20, I gave you 24 divided by 7, huh? 24 divided by 7. Now, then I'm just going to plug this to find, I should say, the coordinates of my angle, because as you remember from your function 11, whenever you are working with this kind of stuff, you have to always, for any point, decide what is the value of the x and what is the value of the y. Okay, this is going to be, let's say it's going to be my x and it's going to be my y. Okay, now, what did we have before? We had the tangent of beta based on the definition. How much is that going to be, guys? The tangent is what?
Y over X.
That's right, y over x. And I know that the tangent is given there, minus 24 divided by 7. Which minus, it means that the x is negative because x in the second quadrant. Then from this information, guys, how much is going to be my x? Going to be 7. And y is going to be what? 24, correct? Because
Yes.
that's the ratio. And based on the thing which I learned, what is the cosine of the beta? Becomes x divided by r, correct? Okay, I know what is the x. I find here x is going to be how much? X is going to be 7. But what is the r? I know from trigonometric, I should say Pythagorean Theorem, that x squared plus y squared, it's equal to r squared. I know x and r. I know that 7 squared plus 24 squared should be r squared. Then I simply get r equals to what? How much did I get? R equals to 25. R is going to be 25. Then now, cosine of the beta becomes how much? Becomes my x divided by r. I know x is going to be 7, and I computed r based on Pythagorean theorem to be 25. How about my sine beta? Sine beta is y over r. How much is my y? I got it 24. 24 divided by 25. And you see that for the second angle, which is beta, I was able to find, I should say, the cosine and the sine of the same angle, because the knowledge of having the tangent of that angle, it helped me to understand how much is x and how much is y. And when I know how much is x and how much is y, it's very easy to find the cosine and the sine, because I know the definition that the cosine is x divided by r and sine is y divided by r. So far, so good, guys. Any questions?
Nope.
No? Linda, Arya, Oliver, Brian, Mingze?
No.
No question.
Good. Then now, what was the task? I asked you to find this one. How much is cosine of alpha plus beta? Because I know the alpha, I know the beta, and based on the identity you learned today, it's cosine alpha, cosine beta, minus sine alpha, sine beta. And now you have everything about these terms. You know how much is cosine alpha, and you know how much is cosine beta, and also for the sine and the sine of the alpha and beta. How much is a cosine alpha, guys? We had it before. Linda solved it. Cosine of the alpha, it was 12 divided by 13. Right, Linda? How much is cosine of the beta? Cosine of the beta, we got it right now here. It's 24 divided by 25 minus sine alpha. Sine alpha, we were given that. I just told you that sine alpha is 5 divided by 13. Multiplies into the sine beta. And for the sine beta, I was able to find it because I know how much is the y and r. It was 24 divided by 25. And that's done. You take the common denominator and do some, I should say, basic algebraic, I should say, simplification. Then you should get the answers to be, I have no space to write. I'm going to write it a little bit on top. I'm going to write it here. It equals to minus 204 divided by 325. And the cosine of the sum of the angles, then you see it's going to be minus, which it means that the angle should be what? On the second or the third quadrant, that the cosine is a -1. Then you see that knowledge of this identity, it just helps you a lot to deal with more complicated, I should say, problems. Okay, any questions, guys?
Mr. Omid,
Yes.
you wrote one wrong, I guess.
Which one?
Cosine beta is 7/25.
Oh, so true. So true. Let me write that. Cosine alpha was 12 divided by 13. Cosine beta is that. So true. Thanks a lot, Mingje. Thanks.
No problem.
7 divided by 25. Is it clear now? This is 725?
Yeah.
Awesome. 725. But the final answer, I just made it right there. The sine alpha is 513. Sine beta is 24 divided. Fantastic, Mingje. Thank you for correcting it. Okay. Guys, any questions? If no, we're gonna take a break In the meantime, I'm just going to post the homework for you, deadline for tomorrow. Then I should say, please come back here by sharp 10:12. That we get ready for the presentation, huh?
Okay.
And guys, please, when you come back, please make sure that you have your camera on, okay?
Okay.
Awesome. I see you guys back in 10:13.